Hi to everyone. In this video, I am just going to discuss about the procedure for the adding the elements onto the multiple stacks as well as to delete the element from the multiple stack. Right? In the last video, we have discussed about the boundary conditions. In this video, we are just going to discuss about its algorithm for pushing and popping the elements. Okay. So here I have defined the procedure. Procedure add I comma x. I is the I is the value ranges from 1 to n. Actually, we are using this value I in order to represent the stack number, right? So here since we are going to push the elements onto the stack, at first we should check for the conditions whether the T of I is equal to B of I plus 1. Why we are going to check for this condition means, since we are going to make use of the concept of multiple stacks, we might have defined some partitions for each stack. For example, you may consider this for stack 1 and this for 2 and this for 3, right? So the topmost, for example, you may take, just have an assumption as I value is equal to 1, right? So here, if the topmost value is equal to B of I plus 1 means, for example, here you can consider this as the T of 1, right? If this T of 1 is equal to the index of the B of 2 means, then we can conclude the memory spaces partitioned for the stack 1 is full. That's why we can call stack full of I, right? So what this procedure will do means, it will just prompt the user as stack is full, and it will return the, and it will just stop the executions, right? In case if this condition is not at all true means, then the program control will come to this line. So there what we have implemented is, at first we should increment the top value. This you know very well. Whenever if you are going to push an element onto the stack, at first we should increment the value of top. Then only we are going to assign the value to it. That's why here we are setting T of I equal to T of I plus 1. That means T of I plus 1 which will get stored in T of I. So after incrementing the value of T of 1, T of I, what we are going to do it, in the corresponding locations we should store the item X. That's why here we are assigning V of T of I equal to X. It means a value of X which will get stored here, right? That's all. And then you can end the add procedure. In the same way, how we have pushed an element onto this stack, in the same way, we are just going to do the pop operations. You don't mean everything which would be same as the just like the add for procedure. But you know very well about the push and pop operations in stack. Whenever if you are going to do the push operations, at first we will increment the value of top, then we will assign the data to that particular locations. Once if you are going to do the pop operations, by that time at first we will retrieve the informations from the stack. That means the topmost element which will get stored in the variable X, right? Then we will do the decrement operations, right? We will just decrement the value of the top. So just like that, that same procedure which will be followed in the multiple stacks also. So here we are defining one procedure as a delete of I comma x, right? So delete is the topmost element of stack I. Here we are going to check for the conditions. This you know very well. Whenever the stack is empty, we are not supposed to do the pop operations. So while doing the pop operations, it's very important to check whether the stack is empty or not. In the previous video itself, we have discussed about the boundary conditions. What's that conditions? If the T of I is equal to B of I, then we can conclude that the corresponding stack is empty. So that same thing, if T of I is equal to B of I, then we are going to call stack empty procedure, empty of I. So this stack empty of I, which will prompt the user as the stack I is empty. Okay. Next, we are going to store the topmost element in the item X. I'm sorry. Then we are just going to decrement the value of top, right? So that's all about it. After decrementing the value, before decrementing the value of top, we may include one more line as V of T of I is equal to null. I'm sorry. After that, you can decrement the value of T of I. That's all. I hope that you got a clear idea about the algorithms for adding an elements as well as for deleting an elements from the multiple stacks. So in case if you are having any doubts in this topic, kindly post your queries. Thank you.